Good afternoon, everyone. Welcome to the BISO webinar for this afternoon. I can see a few people are still logging in, so I'm just going to give it a couple of moments and then we'll come back to you and we will get started. Okay, so welcome everyone and thank you for joining us today. It's really good to see such a strong audience from operations, safety, quality engineering and innovation teams. And that mix really matters because one of the themes we'll keep coming back to today is that AI vision really delivers value when it comes and it cuts across different functions, not when it lives in that silo. So I'm Chrissy, I'm the VP of Marketing here at VISO, and I'm joined by both Talia and Jeremy from our go-to-market team here. So hello to you both.
Hi, Chrissy.
Hello. As a team, we work with customers who are using AI vision in live operations, and that really, I guess, gives us a unique kind of cross-industry view of real deployments. And it's not just what sounds good on paper, but also what actually delivers outcome in production. So what we'll be sharing today is drawn directly from those conversations and those implementations that we see in the market. We work alongside our customers to drive measurable insights that really help to improve everything from operational efficiency through to safer environment for their teams. And working together in operational reviews, kind of safety stand downs, lean workshops, even the bigger transformational programs, we really help deploy AI vision in production time and time again. So we titled this session Vision to Decision Deliberately, because what we're seeing in the market right now is not really a technology problem. It's more than kind of an execution problem, really. And most of the organizations we're working with are already believing computer vision. Many already have cameras everywhere. Some even have sort of in-house models running, but they are asking us deeper and deeper questions now as their computer vision journey really starts to build. We hear a lot, things like, where does AI vision deliver the most value first? How can we maintain really strong momentum after successful pilots? How do you scale across sites without creating operational and organizational complexity? And how do you make sure what you learn through vision really can turn into great decisions? So today's webinar isn't theoretical. Everything we'll talk about is grounded in real implementations. And all of the companies we'll reference, from Cargill and BMW to Coca-Cola, Vinci Group and others, have all deployed AI vision in live environments and learned what works for them and what doesn't. Some of the customers that we talk about are ours. Others are out there doing their own things, but they all have one thing in common, and that really is their desire to use computer vision to drive their business through innovation. So initially we were going to walk through a top 10 list, but there really was just too much to cover in one session. So this has actually now become a two-parter. We will send out a link to sign up to the second part alongside the recording of this session, either later today or tomorrow. Today, though, Talia and Jeremy will share examples, they'll share lessons, outcomes that have caught their attention out there in the field, and most importantly, ones that we think will be most relevant to you all. And then what we'll do is have a big roundup of the full list next time around. So the first 5 themes we're covering today are moving from visibility to causality, Safety systems are still reactive. Defects are process-based, not frame-based. Multi-site learning creates the biggest ROI, and construction is catching up fast. And then we'll follow up on the 18th of February with numbers 6 through 10, which are robotics works, but coordination often doesn't. Inventory visibility versus inventory truth, predictive maintenance needs context, making lean visible with vision, and then most importantly, tying both of those webinars together with turning vision into a decision system. It's quite tricky to say. So our goal for this webinar, though, is simple. By the end of it, you should have a much clearer sense of what good looks like, in some cases where teams get stuck, and also how to avoid learning these lessons the tough way. So let's begin with a pattern we see in almost every AI vision deployment, and that's looking at moving from visibility to causality. Now, almost every computer vision journey starts the same way. So cameras are assessed, data is collected, models are trained until teams can start to see the patterns and risks or inefficiencies that were previously invisible. That new level of visibility is powerful, but it really is only the starting point. The real value comes from turning what the system detects into action. Without clear goals and integration into daily operations, even the most accurate vision models risk becoming passive tools rather than drivers of safety decisions and measurable outcomes. Where organizations really begin to see the value is when vision stops answering what happened and starts answering why it happened. So let's come over to you guys. Jeremy, you've spent time looking closely at what Cargill have built. What made their approach so different?
Thanks, Chrissy, and a warm welcome to everyone. Thanks for tuning in. We're really excited to share these insights today. And Cargill's beef processing operation is just a perfect example of moving past simple visibility. In beef processing, yield loss actually happens in millimeters. Historically, it was really difficult to measure in real time. So operators had to rely on their experience, and supervisors relied on periodic audits, and management got yield data days or in some cases weeks after production. So Cargill developed a vision system that they called Carve and deployed it directly on the processing line themselves. Every single carcass, amazingly, is measured in real time, and waste gets flagged as soon as it happens. That's immediately. But what was so interesting and transformational was they didn't stop at just detection, and that's absolutely key. Once the system was live, operators could then adjust cutting techniques on the spot there and then, not at the end of the shift, but again, immediately. And then those supervisors could see the yield variation by shift, they could see them by line, by operator, and leadership then had the visibility to correlate losses with upstream conditions, working out if it was a training issue, equipment calibration, changes in raw materials, or something connected to a specific supplier. So what Cargill senior executives have said publicly is that Carve shifted yield from a lagging metric into something they could actively manage during production. Yield improved measurably, which is massive for them. Waste dropped, and operator performance became visible and crucially coachable in real time. It's a great result.
Thanks for that, Jeremy. And I'm super happy to be here today and to discuss these themes in AI vision. So just to add on to what Jeremy said, interestingly enough, BMW shows a very similar pattern, just in advanced manufacturing. They use computer vision across things like inspection, paint checks, tracking movement and logistics, and even digital twins. But they don't treat detections as simple pass or fail moments. Instead, what they actually do is look at visual signals along multiple stations and over time. So when defects start showing up together at final inspection, they can work backwards to see what caused them. That could be tooling wearing out a few stations earlier, changes in the paint booth environment, or even a process tweak that happened hours before. The defect still gets caught, but more importantly, the real issue gets fixed before it creates more waste. Several teams at BMW have talked about this publicly. computer vision stopped being just another quality check and started becoming a way of understanding what's really going on in the process. And once people can understand what's happening in the process and understand the cause and effect, they can step in earlier, waste less, and keep things stable. And this is instead of just spotting these problems at the end. And so we're also seeing something very similar with a food manufacturer that we're working with today. So they make about 700,000 units of their main product every single day, but they actually found out that basic sensors showed total output, but they couldn't tell where the losses were actually happening across maybe forming, steaming, freezing, or packing. So a lot of the counting was based on weight averages, which meant that losses at specific steps were essentially hidden. So by switching to vision-based unit counting at each stage, the team could see exactly where things were going wrong and why. And they were able to act on those issues straight away. And the impact was really, really clear. So a previous sensor upgrade had already added around 120,000 extra units per day with no extra resources. Vision was the next step, and this allowed turning visibility into real control of the process.
Yeah, super interesting. I'd say that when teams move from that visibility to causality, behavior, I think, fundamentally changes as well. You know, you see things like the amount of scrap drops because you're stabilizing processes and you're not just kind of detecting bad parts. We also see a lot of rework decline, catching drift, before it produces those major defects as well. So also interventions happen earlier when they're cheaper, faster, and far less disruptive to the operations. And it's amazing how it really can carry across vertical sectors too. I always find this brilliant because so many challenges we see aren't just individual to their own industry. They're just packaged up, I guess, slightly differently. Okay, so turning to our second theme, so why some safety systems are still reactive. And safety, I guess, is one of the most common entry points for AI vision. And many organizations have already developed kind of PPE detection, zone monitoring, and things like that very, very successfully. But despite all of that visibility, serious incidents do still happen. And the question, I guess, isn't whether safety vision works, it's why it so often remains reactive instead of preventative. So maybe, Talia, I'll come to you first on this. From what you've seen, what do you think teams are missing when they stop short at just kind of basic compliance, let's say?
Yeah, so what I've seen for companies like Skanska, the first computer vision deployments were actually pretty focused on the basics, things like PPE detection and monitoring restricted areas. And those systems worked, they delivered real results. You saw immediate violations drop, compliance improved, and safety teams got much better visibility across large, complex sites. But when teams really went back and actually looked at the really serious incidents, the ones that really caused major injuries or shut down sites, they actually noticed something important. Those incidents almost never came down to a single mistake caught on camera, but instead they were the result of lots of risk building and building and building over several weeks, maybe even months. There were near misses that no one actually connected. Congested areas might have pushed workers into makeshift workarounds or fatigue during high pressure phases of the job. And small shortcuts slowly became, that's just how we do things here. It's just how things get done. Traditional safety vision systems weren't built to spot that kind of buildup, to be honest. They're typically very binary. If a violation happens, an alert gets sent, but they don't show how risk is growing over time in certain areas during specific activities or with particular contractors.
Yeah, it's really well said, Talia. And I just find it fascinating to Chrissy's point before that it's a similar story across verticals. So large infrastructure projects like HS2 for rail here in the UK, for those who are familiar with it, teams started off by analyzing visual data longitudinally. I'm glad I got that word right. Not just looking at individual violations, but they were tracking patterns by activity type, tracking them by project phase, and also by differing site layouts. interestingly, what they discovered was that certain combinations consistently ended up producing higher risk. So whether it was a specific phase of tunneling work combined with particular site layouts, that would create something that was predictable in terms of congestion. And then that congestion would lead to, I don't know, people taking shortcuts, clustered near misses, and that eventually led to those serious incidents. Once they had that insight, they didn't only then end up enforcing PPE rules harder. What they did was they were able to take it back to how work was planned. And so that meant adjusting sequencing to reduce congestion, maybe increase supervision during high-risk phases, and crucially redesigning site layouts to get rid of, completely eliminate the major choke points. Another interesting example that I found was Costain, who were part of something I hadn't heard of before, the Safety Technology Accelerator. That's the very first non-profit accelerator dedicated to industrial safety and risk. And Costain have been really open about using AI vision, not just as a tick box exercise for compliance, but for risk prediction. So they analyze video data to identify leading indicators, those patterns that come before incidents, and then they can intervene before harm occurs. Another customer in construction that we work with has seen incredible results. They operate high-risk drilling sites where always-on AI visions replace periodic inspections with continuous risk detection. In just 12 weeks at a single site, that system identified over 150 safety incidents. I think it's 154. And that included 49 near misses involving unsafe proximity to heavy machinery, allowing teams to intervene before harm occurred. So that's a lot for me, but I think the key message is those insights led to changes in site layout, supervision, and work planning. And that delivered an estimated $300,000 in instant-related cost savings per site, all driven by earlier intervention and not stricter enforcement.
Yeah, so we can definitely see that safety teams are starting to shift from that enforcement into prediction. Instead of reacting after something went wrong, they kind of focused resources where risk was demonstrably increasing. The result we consistently see across our deployments are measurable reductions in serious incidents without slowing that work down or adding any kind of bureaucratic overhead, which is great. Workers, interestingly, they're not being policed more. Work was just designed to be safer from the start. Okay, so let's move on and look at quality. Our third theme is that defects are process-based, not frame-based. So most defects are not caused by a single moment captured in an individual frame or of a video or a still photo. They're generally caused by a process that has been drifting kind of unnoticed, I guess, and unobserved until that major defect occurs. Automated inspection has become incredibly good at spotting defects in kind of individual frames faster and more consistently than any human could. And yet quality teams still get caught off guard by these sudden scrap spikes, these reworks, or even recalls. So, Jeremy, what do you see happening in those situations?
Yeah, sure thing, Chrissy. The key aspect here, I'd say, is about context. So a really good example here is Coca-Cola, who have deployed AI vision on bottling lines, and that's for things around detecting defects in real time is probably the big catch-all. And the focus was on specific issues like label misalignment, cap issues, fill levels, contamination. And initially, as per Tyler's example before, it started off as really simple pass-fail detection, and it worked. Defects were caught faster than human inspection could manage. That's a no-brainer. But quality teams then realized something far more important, and that again is that these defects didn't appear out of nowhere. They came out of processes that were just gradually, minimally losing stability. So it's a very slight drift in the fill level for a bottle or can, or cap alignment starting to vary, or the tension of the label on the product changing incrementally. Individually, these are all within tolerance. They're micro shifts, but collectively they signal that there's a process that's starting to drift towards failure. And once teams working together started correlating those visual signals across multiple stations, across time windows, they could then crucially intervene before the defects appeared. So they saw that early stage drift. They could get in and adjust settings. They could trigger the maintenance that was needed. They could switch material batches, and they could coach operators as well where needed. So the line ends up staying stable instead of swinging into scrap. What we've heard incidentally from Coca-Cola engineering teams talking about this is that this actually ended up fundamentally changing their entire quality strategy. So again, it's this switch from reactive defect detection to a more proactive control of process. Scrap rates dropped, line stoppages decreased, and costly downstream issues from rework, returns to recalls all have become far less frequent. It's a great example.
Yeah, that's really great, Jeremy. And just to piggyback off of that, continuing in the food and beverage industry, is Tyson Foods, where they use computer vision in their poultry plants. So they started with use cases like defect detection, spotting foreign objects, and also improving yield. But it's the same idea, really, again. So vision isn't just catching problems, it's showing when upstream processes start to drift. So by looking at these trends across the production runs, not just one product at a time, teams began to see the clear patterns. When yields started dropping on certain lines, the vision data showed links to things like specific equipment conditions, shift changes, or even certain raw material batches. So they took that insight and they realized that they were able to just step in early to maybe recalibrate the equipment, tweak workflows, or switch suppliers before those yield losses really started to add up. And the results Tyson has shared are pretty clear, to be honest. Yield went up, waste went down, and product consistency improved overall. And the key reason is that vision was able to help them understand how the process behaves, not only just flag defects on individual products.
Yeah, it's super clear that computer vision kind of helps organizations move that quality control from detection to prevention. Teams seem to gain predictability. It seems that they're less likely to be surprised by those sudden scrap spikes because they can see that instability developing for sure. They're certainly reducing waste, protecting the throughput, avoiding the potentially catastrophic costs of late-stage quality failures too. And what I take from both of you there is that recalls, customer complaints, regulatory issues all drop too by stabilizing those processes before they produce those defects. Okay, so moving on to what matters to so many is tangible outcomes. So let's delve into our fourth theme, why multi-site learning creates the biggest ROI. So many organizations deploy AI vision successfully at a single site and they see real local gains. However, oftentimes the biggest returns don't come from isolated or quick wins at just a single site. They come from scaling their learning across their networks. So, Talia, what does this look like in organizations that are doing it really well?
Yeah, so just to touch back on food and beverage manufacturers, with this example, they're actually one of the best examples of multi-site learning. So they run dozens of manufacturing plants around the world, and computer vision is used across several domains, including inspection, quality, and logistics. And what makes their approach really powerful is that insights from one plant don't just stay local. So if a plant maybe in France figures out that a certain setup sequence reduces packaging defects, that insight doesn't just stay with that plant specifically. So the visual evidence, exactly how that setup is done, will become available straight away to plants everywhere in their network. And this could be from the US to China, from Mexico to South Africa. And if a quality issue shows up at one site, other plants can look at their own vision data and see whether the same pattern is starting to appear in their own facilities before it turns into a real problem for them as well. So that's where the value really starts to stack up. And vision deployments don't just fix one local issue, they create learning that improves performance across the whole network. Best practices spread in days instead of months. Problems get solved once instead of being rediscovered again and again and again at different sites. And standardization improves because teams can actually see what good looks like instead of trying to interpret it from written procedures that lose context, especially over time. So, the most successful deployments treat vision as a company-wide learning system, not just a specific tool at a specific single site. And that's why the return keeps growing over time instead of flattening out after the first rollout. And it compounds even further as new use cases are built on top and added.
You're spot on there, Talia. That compounding bit's absolutely key, and we love hearing about and talking about ROI. It's essential to see that focus. So we've seen, as Chrissy talked about, across verticals before, similar patterns in food processing, logistics, and all the way through to construction as well. I'll always keep banging on about Cargill. I love that example. Yield improvements actually discovered at one beef processing plant get shared visually across their whole network. So those other plants can see exactly what the top performers are doing differently. And so changes in cutting techniques, equipment settings, quality checks, all of that best practice can be adopted immediately. A good example in logistics would be FedEx. So when one distribution center optimizes loading patterns or parcel routing using those insights from computer vision, those patterns get tested and deployed all the way across the network. So think about that scale and compounding value. The investment in figuring out what works happens once, but then that benefit just multiplies across hundreds of sites. And I think for where we've got to now with the maturity of the market, the key distinction is architectural and, most importantly, cultural. Organizations who are achieving this compounding ROI have built platforms that allow visual data and insights and decisions to flow across sites. They've actually created cultures where sites are actively sharing learnings instead of operating perhaps the way they used to as isolated silos. And they've structured their improvement programs to capture and validate and then scale those best practices systematically.
Yeah, we definitely see that across all of our multi-site customer base. Standardization improves without heavy bureaucracy because best practices really are demonstrated visually, not just documented in text. So underperforming sites catch up much faster because they can see what top performers do differently, and new sites brought in then ramp far faster because they start with those proven practices instead of learning from scratch. And knowledge that I guess previously took years to spread now transfers in weeks. So the ROI from investment compounds each additional site benefits from all of those learnings generated by those previous deployments. Okay, so finally looking outside of manufacturing and logistics, theme 5 is how construction is catching up fast. So construction and infrastructure can sometimes be seen as kind of too dynamic, too temporary, too variable for the kinds of operational intelligence used in manufacturing, but that's changing very, very quickly. Vision is starting to unlock patterns even in these highly variable environments. So Jeremy, what's driving that shift and what are construction teams learning from these deployments?
Thanks, Chrissy. We're seeing for our client, Vinci Group, and other leading construction companies, vision is just being used in so many ways now. Safety, analyzing risks, tracking project progress, all the way through to monitoring equipment movement, and even understanding, productivity of the workforce. What I think is interesting is that even though each project is unique, different location, different scope, different teams, there's patterns that emerge when you analyze video data across those multiple projects, even though they're all unique. So major global construction companies have been using vision across dozens of infrastructure projects to identify which phases of construction generate the biggest safety risks, and then which types of site layouts create congestion and force unsafe workarounds, and which activities then precede the incidents most consistently. And once they've got those patterns, the leading deployers of computer vision in construction didn't just react to potential incidents after they happened. They changed the very nature of planning their projects. So for Vinci Zero incidents, it's not a target you reach by analyzing accidents after they happen. It's something they specifically designed for up front. They're not waiting for incidents or near misses to learn from, and they don't treat injury statistics as a primary measure of safety performance. The focus really for construction has shifted to identifying and removing risk conditions early. So eliminate those blind spots, get rid of unsafe interactions at source, reduce hazardous situations before anybody gets hurt. And that philosophy is exactly where AI Vision's played a critical role. Vinci used vision not to document what went wrong, but to continuously surface leading indicators of risk across live construction sites. I just think that's massive, because that could be people working under suspended loads, unsafe proximity between workers and machines in blind spots, entry into exclusion zones, PPE non-compliance before the workday starts, housekeeping hazards before they cause trips or delays. There's just so many use cases there. They've seen that the real value of AI vision is that it prevents incidents that never appear in a report. And this reinforces a simple truth. The most meaningful safety outcomes are the ones that don't happen. So when risky behavior stops, interventions happen earlier, and work can be designed and planned to be safe by default rather than corrected after the fact.
So if I can jump in here, what I've also seen is that most leading construction firms show similar approaches. So they'll use vision for progress measurement, comparing actual site conditions against their planned schedules, for crane monitoring to optimize logistics and prevent conflicts, and finally for safety risk prediction. And what makes this especially powerful in construction is that learning carries forward across projects. And on a typical construction project, when the site closes, considerable amounts of the knowledge actually walks away with the temporary workforce, which is a huge loss for the firm. However, when this visual data is analyzed systematically across projects, and they really hold on to that information, patterns persist even as the teams change. And a site manager starting a new project can then see visual evidence of what worked and what didn't on similar projects. They can choose to identify risks before they materialize because they've seen those patterns before. They can also optimize sequences and layouts based on this data from dozens and dozens of previous projects, not only their own personal experience on 2 or 3. The construction sector is also learning from manufacturing's decades of experience with operational intelligence. They're applying the exact same discipline, measure, analyze, predict, and improve methodologies. Construction businesses adapt to the unique constraints of their sector, temporary sites, variable conditions, and those constantly changing teams, as I mentioned.
Yeah, for our construction clients, projects certainly become safer because risk patterns are identified and addressed proactively. I just think schedules become more predictable because progress is tracked visually, deviations are caught early. There's just so much to it. I think also you see efficiency improving because teams learn what works across projects and they just apply that knowledge systematically. And I think critically, learning persists across projects instead of it disappearing when that site closes, like you mentioned, Talia. And that just means each project genuinely benefits from the experience of the previous one, which is amazing. Okay, so time for a quick roundup before we move on to your questions. We've obviously covered 5 of our 10 themes today, and they're all drawn from those real deployments across manufacturing, logistics, constructions, agriculture, healthcare, retail, etc. And I guess the organisations we've discussed aren't simply experimenting. They really are operating AI vision at scale in those production environments and learning what works. So if there's one message to take away, I would say it's this. In execution is now the challenge, not the technology. The technology works, models are accurate, infrastructure is definitely affordable, integration is achievable. The questions are strategic and operational. That's more about where do you start, how do you scale, how do you turn detections into decisions, and how do you avoid the lessons others have learned the hard way. So I think everything we've shared today is designed really to help you answer those questions faster and with greater confidence. And just before we move to Q&A, I want to remind you, if you want to explore how any of these themes apply to your specific operations, we'd be happy to continue the conversation, of course. If I can also point you to our health and safety toolkit in the resources section of our website, you'll find a set of free tools like our ROI calculator, use case builder, and also a comprehensive safety audit that I'm sure you'll find very useful for getting started. Okay, so we've opened the floor to your questions, and I can see we've had quite a few come through. So we'll do our best to answer as many as we can in the time we've got remaining, which isn't too long. Okay, let's take a look. Jeremy, I'll start with you on this one, I think. So many organizations have already run AI vision pilots. Why do many struggle to scale beyond that first use case?
Thanks, Chrissy. Yeah, it's definitely a question we get asked a lot. And from our perspective, we do see organizations that struggle to scale because some of those early pilots, simply they're not built on a scalable platform. And that then quickly leads to cost soaring, quite significant levels of planning uncertainty, and underutilization rolled out across the wider organization. So when pilots are developed standalone, each and every additional use case then needs further development, fresh integrations, and even greater operational efforts and crucially coordination across teams. So what starts as a small controlled investment can rapidly spiral, and it ends up becoming considerably expensive and difficult to manage. Without the platform at the outset, expanding to more cameras, sites, and applications just leads to those costs growing exponentially, Chrissy, rather than predictably. So a scalable platform approach makes this avoidable by standardizing that deployment, standardizing model management and operations. And that keeps costs linear and transparent. I'd say, that just all makes it far easier to justify expansion and long-term ROI. So we also see that a platform removes the planning challenges that can delay and stall scaling. Where you've got centralized control and deployment patterns that are repeatable, organizations can confidently plan the next rollouts across sites, across different teams, just knowing in advance what it takes and what it took last time in terms of time, infrastructure, and all the resources they need. And then I think the final point for me is that a scalable platform maximizes value across the wider organization. So instead of AI vision being locked into a single pilot or department, the same infrastructure can support multiple use cases. And we see this across safety, compliance, quality, and then operational efficiency, for example. Yeah. So in summary, given a long answer to a short question, but we see AI vision only truly scaling, I'd say, when it becomes a shared platform-driven capability. And that's one that controls costs, enables planning to be predictable, and allows that value to compound across the entire organization.
Yeah, that's great. Really good. Very, very comprehensive. Thanks, Jeremy. Okay, one for you, Talia. I think, looking at the time, we're at 22, so I think we'll just do this question and we'll come back to everybody else on others that have been asked. But Talia, one for you. How do you avoid AI vision just becoming another dashboard that people stop looking at?
So that's a great question. Thanks for asking it. In my experience specifically, what we normally see is that the real difference comes down to how dashboards are designed and how they're actually used. So in the strongest deployments, the dashboard isn't just somewhere where maybe you go to look at data. It actually becomes more of a shared view of what's really happening there. So teams use it to see what's going on across sites or use cases and over time. And this is just in one place. So it's really, really nice to have this data centralized where it's accessible and quite visual. And this makes it easier instead of jumping between lots and lots of disconnected tools. And this shared visibility really matters because it gets operations, safety, quality, and engineering all working from the same set of facts. So what really takes dashboards to the next level, though, is the layer of analysis that is put on top. So instead of just raw detections or basic counts, teams can start to see trends and patterns, which are early signals that show risk might be building. Maybe yield is starting to drift, or performance could be different between a couple of sites or different shifts. So once teams are able to look at those insights and they're connected into their existing systems, maybe it's a maintenance, safety, quality, planning tools type of system, the dashboard stops being something where people check every now and then, and it becomes a vital part of the organization actually running on. This is where adoption really sticks because the data isn't just visible anymore. It's useful and connected, and it directly supports how work is getting done and how decisions are being made.
Perfect. Thank you so much. Okay, so I do think that's all we've got time for today. There are some questions in there. We will reach out. I can see names against them. So we will reach out directly to answer any questions directly to those of you that have submitted them. So thank you so much to you all for joining. And my thanks again to Talia and Jeremy. We'll be rounding out the top 10 with the final 5, as I mentioned, on the 18th of February. So just keep an eye out for that one, and we will work our way through those too. As ever, please do feel free to reach out with any other questions. Keep them coming. And we will very much look forward to seeing you next time around. So thank you for tuning in. Great to have you all here today, and we wish you a great rest of the day. Thank you very much. Bye-bye.